Right, welcome to the next video. It's going to be fairly short, this one, because we're going to be covering something you've done before. You'll spend some time on this in third year. We will go into it in more detail later. We just need to remind ourselves of it now, because it forms quite an important part of the dynamics topic, and that is acceleration. So we should all be familiar with what it is. Acceleration is just when the velocity of something is changing. And remember, because it's a velocity that's changing, velocity is a vector. So if you're asked about it, acceleration is also a vector. Now, how much the velocity changes every second is what acceleration is. So as you know, or should know, the units for acceleration are meters per second squared. So it's meters per second. How fast is it going every second? And so, example here, an object accelerating at 3 meters per second squared is getting 3 meters per second faster every second. Now, we know enough there to do a formula for this, and it is given to you, but you need to be familiar with it. So we define acceleration as the rate of change of velocity. So it's the change in velocity divided by the time. And that gives us this formula, where acceleration, your A here, is v minus u over t. So v, that is your final speed. So that's whatever speed the object has finished up at. U here, that is your initial speed. So that's what speed it started at. It's really important you get these the right way round. The way I always remembered it was v comes after u in the alphabet. So v is the speed that comes after the starting speed. We know all the others. T is your time measured in seconds, and A is your acceleration measured in meters per second squared. You could also, instead of ms to the minus 2, you could write it as m/s squared, like that. That's normally the way I would write it actually. So if I do worked examples on the board or worked solutions, I'll most likely do it as the m/s way, but ms to the minus 2 is correct also. Right. We know lots of uses for accelerations. We know when we see them, we know what acceleration means. We've got all our standard things like vehicles accelerating, getting faster over time. Generally, we're thinking cars, things like that. Also, you've got aircraft, stuff like that. These are all standard things that would come up in questions you would get in past papers or in the exam. But you will also get acceleration in other contexts. You might get it in something a little bit weird, like a roller coaster. You might get it for things, balls being thrown through the air, things falling from the sky. Okay, there's lots of different situations you can see acceleration in, but the only thing that really matters is that it is how the velocity is changing. Doesn't matter about the situation, not at this point anyway. So let's look at a worked example, but first, because I forgot this was here, let's talk about deceleration. So, fairly obviously, and hopefully that you know, if the final velocity is less than the initial velocity, so when an object is slowing down, that would give you a negative acceleration. And so we can say then a negative acceleration is called a deceleration. Something is slowing down. So if you worked out an acceleration and got negative 10 meters per second squared, that's fine. But that's the same as a deceleration of 10 meters per second squared. Right, now let's look at a worked example. So a bobsleigh team will reach a speed of 55 meters per second from rest in 10 seconds when starting a toboggan run. Calculate the acceleration. So our first step here, like with all these questions, is to write down what we know and what we're trying to find. So straight off, we know a time here, 10 seconds is a time. And then we're given two speeds. We're only given one of them as a number, and we have to sort of infer the other one. So it says a bobsleigh team will reach a speed of 55. So that means that 55 is their final speed. So that is V. And it says they'll reach that speed from rest. Rest is what we use in physics to say something isn't moving. It's under no external forces. It's just sitting there still. So this rest here, that is its initial speed, u, and that means its initial speed is 0 meters per second. So that gives us everything we need to work out the acceleration. We've got the final speed is 55, initial speed is 0, time is 10 seconds. So we write down our equation, a mark there for writing that down, and then we substitute in 55 minus 0 over 10, work that out. That gives us an acceleration of 5.5 meters per second squared. That's your standard acceleration question, and it's quite common to see, okay, it starts at rest or it finishes at rest, and so you need to spot that means 0. You will, however, more likely be asked something where you need to rearrange it. So that's what we'll look at for this next worked example. A car accelerates at 4 meters per second squared for 8 seconds. If its initial speed is 6 meters per second, calculate its final speed. So, straight away again, we know the acceleration, that's 4 meters per second squared. We know the time here is 8 seconds. It tells us its initial speed is 6 meters per second. Remember, initial speed is u. And we're trying to work out the final speed. So let's write all that down. Now, that's our normal equation for acceleration. We need to rearrange this though to get the final speed instead. You can go through this process of how to rearrange it if you wanted. We'd move this t over here and it would become a times, and that would give us a t equals v minus u, and then we'd say, okay, well, I need this v by itself, so we'll move this u over and it will become a plus, so that then would give us v equals u plus a t. However, there's no marks for rearranging it properly, and you'll be using these rearranged forms quite often, so quite handy to just remember, if you can, the rearranged form. Hopefully though you are comfortable enough rearranging it. So there we go, we've done one step of it and the other. So our final speed equals the initial speed plus the acceleration times the time, and we just substitute in. So it means v equals 6 plus 4 times 8. So v equals 38 meters per second. And again, we could write that if we wanted to as 38 m/s rather than ms for -1. Both of those are correct. So that's all we're going to do in this little video, and the questions we're going to look at are just using this formula, just to remind yourselves of it before we start looking at some more complex examples. So hopefully that was all understandable, and if you've got any questions, you know how to get in touch. Thanks for watching.